Welcome. This question says a 12 volt EMF is applied across the resistor network. What is the current flow through the 2 ohm resistor? So let's just redraw this. We have 12 volts EMF and it's coming down, it's entering into a parallel section. And then we have a series part. So this is 12 volts. And this is 4 ohms, this is 2 ohms, and this is 6 ohms. Here I'm using the American symbol for the resistor, which is a squiggly line, and over here I use the European symbol, which is the square with a value put in the middle of it. Okay, so what's our principle? Our principle is, remember, always try and solve things in one step. So the current through the 2 ohm resistor is equal to the voltage across the 2 ohm resistor divided by the resistance of the 2 ohm resistor, which equals V2 over 2. And the problem is I don't know what the voltage across the 2 ohm resistor is. But I do know that the voltage across the 2 ohm resistor is the same as the voltage across the 4 ohm resistor. And I do know that the voltage across the 2 ohm resistor added to the voltage across the 6 ohm resistor is the same as the EMF. So my second leg would be the voltage across the 2 plus the voltage across the 6 is equal to my EMF, VEMF. So I can say, oh, my voltage across the 2 is equal to, the EMF is 12 minus V6. Okay, so then the next bit would be, well, I don't know the voltage across the 6. But what I do see, well, let's do the next step. The voltage across the 6 is equal to the current flow through the 6 times the resistance of the 6, which equals, well, the resistance of the 6 is 6, so this will be 6I6. Okay, if I knew I6 I could find the V6. Yes, okay. And the next step would be, I'm going to go over here. The current flow through the 6 is equal to the current flow through the system. And what I mean by that is going into and out of the power supply. And then where do we go to next? And we say, yeah, the current flow around the system coming into and out of the battery is equal to the voltage drop of the system, which is the EMF, over the resistance of the system, which equals 12 volts over our system. Okay, so then the next bit is, how can I get this resistance of the system? So let's go, we've kind of been here before. We're going to do this in stages. So this is a 4 ohms, this is a 2 ohms, and this is a 6 ohms. So the first thing to recognize is, let's do this parallel bit. This parallel bit is kind of unambiguously in series with the 6 ohms. But if we try to do the series bits first, would you take the 6 with the 4 or would you take the 6 with the 2? So that's not the way to go. Do the unambiguous bit first. So I'm going to remember that 1 over R parallel is equal to 1 over R1 plus 1 over R2, which equals 1 over 4 plus 1 over 2, which equals 1 over 4 plus 2 over 4, which equals 3 over 4, Now here's the kicker. If you're not careful, if you're not writing complete sentences down, if you're doing this in your head, it's easy to forget that this is 1 over Rp. So Rp is actually equal to 4 over 3 ohms. You got to flip it. So now we have a system. I'm going to draw it kind of like down here. We have 4 over 3 ohms plus 6 ohms, which is given by our system is equal, our series is equal to R1 plus R2, which equals 4 over 3 plus 18 over 3, that's what 6 is. 18 over 3 equals 22 over 3 ohms. Okay. So now we can just backtrack. So we take this round to here and we say, okay, so this I system is equal to 12 over 22 over 3, which is the same as 12 times 3 over 22, which equals 36 over 22, which equals 18 over 11. That's going to be amps. That's the current flowing around there. And then that means that I6 is equal to 18 over 11 amps, and that's the current flowing through there. And so we go along here and we say, oh, well, in that case then V6, that's the voltage drop across there, that's V6 is equal to 6 times 18 over 11, and that's going to equal 60, 6 8s are 48, 108 over 11, and this is volts. Now let's work out what this is. 108 divided by 11, so that's going to be 9.82, which equals 9.82 volts. So now we take this and we kick it round here, and so our voltage drop across the 2 is going to equal 12 minus 9.82, which equals 2.18 volts. And so we kick this back up there and we say, okay, this is equal to 2.18 volt, forget the volts, you don't have to put our units in. 2.18 divided by 2, which equals 1.09 amps. Now we need our units in. There we have it. I can do a quick check, I think. My current through my system is 18 over 11. So let's go 18 divided by 11. So my current flow here is 1.64 amps basically. That's what that bit told me there. And what it does is, it's the same here, 1.64 amps. And then it divides, and most of it goes through the 2 and some of it goes through the 4. and it splits up according to the ratio of the currents. So the ratio of the currents is basically, well, 4 and 2 make 6. Divide it into 6 bits, and 4/6 go through the 2 ohms, because that's the small resistor, so it gets the big current, and 2/6 go through the 4 ohms. Well, 4/6, let's just take that. I'm going to take 1.63 and multiply it by 4, enter, divide it by 6, enter, and I get 1.09, which is the answer I got here. So a quick check. You can do quick checks by looking at the ratios of things. So there we have it. I don't know what you think about it. It's a relatively long process. This is the slow and steady way of doing it. Ratios can make things quicker if you get comfortable looking at the ratio of voltages or the ratio of currents. But I think that's a secondary skill. I think the primary skill is being able to disentangle networks like this and be able to work out what's the voltage across the 2, or what's the voltage across the 6, or what's the current across through the 4, or the current through the 2, and different patterns of resistors. And basically the way I find that it works, it's slow but it's steady, is that I try and solve it in one step, and then I say, well, what do I need to know? I need to know V2. What do I know about V2? Oh, V2 plus V6 equals EMF. Okay, how can I find my V6? Well, the V6 must equal the current flow through the 6 plus the resistance of the 6, and so on. You keep going backwards and forwards. And when you first learn these things, they're slow, very slow, but with practice you can get to the stage where you can confidently work your way through things. So there we have it.